Hi, good morning. In this section, I will go over how to find the 6 trigonometric functions of a right triangle. I will also go over how to find a missing side length and a missing angle of a right triangle. So for right now, this only applies for right triangles. Okay, so as you can see in the picture, we have what's called a right triangle because over here we have a 90-degree angle, right? And these are two legs. We also call them adjacent or opposite side, depending where theta is. So here's theta right here. That's our unknown angle. And then, yes, so basically these are two legs. So this is the adjacent. So here's theta. So it depends where your theta is. So over here, if your theta is right here, we have, this is called the adjacent side. And then if your theta is still right here, we have an opposite side. So it really depends where your theta is, because if your theta was here, we would have, this no longer would be the opposite side. This would be the adjacent side. And then this would be the opposite side, right? So it really depends where your theta is. And then the hypotenuse is, a lot of people always ask me, well, how do you know where is the hypotenuse? The hypotenuse always goes with the biggest angle. So as you can see, this side length right here, the hypotenuse goes with this 90-degree angle. This little box represents 90. So as you can see, this is the biggest degree, 90. This is these are all acute, less than 90, right? So this is why this is called the hypotenuse. So here are some formulas you have to go over. So I think 1 through 7, you ready? This should be familiar from the last section. So we have here's the 6 trigonometric functions: sine, theta. Now x could be, I said x, but it could be any angle. So it could be theta, alpha, beta, gamma, whatever. So sine of x equals opposite over hypotenuse. Cosine x is adjacent over a hypotenuse. Tan x is opposite over adjacent. Cosecant is hypotenuse over opposite. So it's just the opposite of sine, right? Cosecant is just, you flip the sign. So that's how you got hypotenuse over opposite. Secant is hypotenuse over adjacent. Like I said, as you can see, if you compare secant with cosine, you would see that the difference is that they just flipped it. And then tangent is opposite over adjacent. And then cotangent is adjacent over hypotenuse. So as you can see, if you compare the tan and the cotan, they're just the opposite. So it's just the reciprocal of this. And then there's a way you could figure out you could find, if you ever get lost trying to figure out what is sine or cosine tangent, there's a little trick you could use. It's called SOHCAHTOA. I always use this because I can sometimes do forget because I am human. So sine, this S stands for sine. So it's sine, and then this O stands for opposite over hypotenuse, right? And then co stands for, the C stands for cosine. Cosine is adjacent over hypotenuse. And then tan is, this O stands for opposite over adjacent. Okay. So yeah, so then you just have to remember that cosecant is the reciprocal of sine. So just flip this, and then secant is the so how do I remember this? There's a little s in cosecant, so I know that, oh, that must be the opposite of sine. And then there's a little c in secant, so that I know maybe that should be the opposite of cosine. Okay. And then we have to go, there are some Pythagorean identities. This one is probably the most common one. Sine square theta plus cosine square theta equals 1. Now, and then you have these other two formulas. 1 plus tangent square theta equals secant square theta, and then 1 plus cotangent square theta equals cosecant theta. Now, I think you only have to remember this, sine square theta plus cosine square theta. So on the test, if you forgot your formulas, what you can do is start with the cosine square theta. Now, if you divide both sides by sine square theta, what do you get? This becomes 1. This rate, sine square over sine square theta is 1. And then cosine square sine is the equivalent to saying tan square. And then 1 over sine square is the same thing as secant square theta, right? So then you have this formula. So I think all you have to remember is this, and then you either divide everything by sine square theta or cosine square theta. So, right? And then if you divide everything by cosine square theta, you would get number 10, right? You would eventually get this formula. So I think all you have to remember is this, and then, or just memorize it all. Just memorize it all. What if you can do that. So those are the formulas we're going to use for this section. Okay, so let's start with the first example. So example 1 says find the values of the 6 trigonometric functions of theta. So 6 trigonometric theta. So here's theta, right? We're not trying to figure out what the angle theta is. We're just trying to figure out the 6 trigonometric functions. So what we mean is we have to find sine theta, cosine, tan, secant, cotangent, and cosecant. So in order to do that, we got to find this missing side length, or the missing hypotenuse, right? Because this is a hypotenuse because it goes with this angle, and this is the biggest angle. So how do we get to find that angle? We're going to use, well, some people already know that this is definitely a 3, 4, 5 triangle. But if you didn't know that, you can use the Pythagorean theorem, right? A squared plus b squared equals c squared. So the A and B represents the 2 legs, which we have. And then the C represents the hypotenuse, which we don't have, which we can find because we have 2 legs. So one of our legs, it doesn't matter which one you use as long as it's a leg. So we'll use A as 3. So it's going to be 3 squared plus, and then one of our other leg would be 4 equals c squared, because we don't know that. So 3 squared is 9 plus 4 squared is 16 equals c squared. 16 plus 9 is 25. And then take the square root of both sides. You get c equals 5. So that c means that's our hypotenuse. So this side length here is 5. Perfect. Now all we got to do is find the 6 trigonometric function. So what I'm going to do is I'm going to use SOHCAHTOA because at least I could find my 3 main ones, and then I could find the other 3 by taking the reciprocal of those. So let's start with sine theta. So sine theta says it's, based on SOHCAHTOA, is opposite over hypotenuse. Okay, so it depends. So you have to always make sure where your theta is. So our theta is right here, right? It would be different if our theta would be right here, right? So you have to know first, figure out where theta is. That's very important. And then, so we figure out here, then can you tell, or do you know where the opposite side? So this 3 is not the opposite side. This is the adjacent side. So the opposite side would be 4. And then over hypotenuse, where's I hypotenuse? It's 5, right? So that's why sine theta is that, 4/5. Let me circle it. Let's find cosine theta. Cosine, based on SOHCAHTOA, it says it's adjacent over hypotenuse, right? So here's our theta. Can you tell me the adjacent side? The adjacent side is 3. and then my hypotenuse is 5. Okay, that's what I got. Let's find tan. Tan theta specifically said is opposite over adjacent, so opposite over adjacent. So here's my theta. Where's my opposite side? 4, right? And then over my adjacent side. Where's my adjacent side? 3. So that's how we got 4/3. Now let's find 3 more, the secant theta. So secant theta. So I know this is, secant theta is the opposite of, there's a C here, so that means it's the opposite of cosine. So all you got to do is look at your cosine. What's the reciprocal of 3/5? 5/3. That's all you have to do. Or you could, if you didn't know that, you could remember that secant is the same thing as 1 over cosine theta. So I know this is probably even more confusing, but it's okay if you forgot. What is our cosine? It's 3/5. And then I'm going to use the bracket. You would still get 5/3. So either way works. Let's find cotangent. So cotangent is the reciprocal of the opposite of tangent. So where's my tangent? Is right here. So it's 4/3. So the reciprocal of 4/3 would be 3/4. Okay, and then let's find cosecant theta, our last one. So cosecant theta is, you can think of it as the opposite of sine, right? So the opposite of sine is, or the reciprocal of sine is 5/4. Or you could think of it as adjacent over hypotenuse, right? It still give you the same answer. Adjacent is 3. Whoops, did I make a mistake? Yeah, no, I did not. Adjacent is, cosecant is, where's, adjacent over hypotenuse. So adjacent is 3 over, wait, actually you could think of it as 1 over sine theta, right? So 1 over sine theta is 1 over, and then sine theta is, where's sine theta? 4/5. And then do your bracket. And then multiply both sides by the common denominator, which is 5. So you would still get 5/4. So you could just take the reciprocal of sine and you would get 5/4, or you could think of it as cosecant as 1 over sine theta, which is 1 over 4/5, and that would still give you 4/5. Okay. So that's how you find the 6th trigonometric function for this example. Okay, let's move on to example 2. So example 2 says, find the values of sine 45 degrees, cosine of 45 degrees, and tan of 45 degrees. So here's your triangle. This is your, this was given. I like this kind of triangle because you have 2 45s, so that's pretty simple. So first thing I'm going to do is write out my SOHCAHTOA. Okay. So they want you, let's find sine of 45. So I like this one because they both have 45s, but I'm just gonna, when you do this, just pick stay with the same 45. So if you're gonna pick this 45, just stick with it, even though you'll still get the same answer, but it's just good to stick with the same angle. So sine of 45 is, so here's 45. What is sine? It says is opposite over hypotenuse, right? So here's 45. Can you tell me where my opposite side is? The opposite side would be this, right? Would be 1. And over hypotenuse, right? What's my hypotenuse? Is radical 2 because this side length, this side right here goes with this angle, which is 98. So that's the biggest angle. So my hypotenuse is radical 2. Now, Usually your teacher wants you to rationalize the denominator, meaning he or she doesn't want the radical in the bottom. So what you're going to do is, to get rid of that square root, you're going to multiply top and bottom by square root of 2. Okay, so multiply across, because we are multiplying fractions. So 1 times square root of 2 is square root of 2. And then square root of 2 times square root of 2 is just 2. Okay, so this is that. Now let's find cosine of 45 degrees. So we'll still stick with this angle right here. Cosine says it's adjacent over hypotenuse. So where's my adjacent side of this angle? 1, this, right? And then my hypotenuse is radical 2. So you can't have a radical in the bottom, radical in the denominator, so you're going to rationalize it by multiplying top and bottom by square root of 2. So you would get square root of 2, and then square root of 2 times square root of 2, that just becomes regular 2. Okay, and then the last one says find tan of 45 degrees. So TOA, so tangent is going to be opposite over adjacent. So here's my theta, my angle. Where's my opposite side? My opposite side would be here, this one. And then my adjacent side is this one right here. So your tan of 45 is just going to be positive 1. Okay, I hope that helps. So that was example 2. Let's move on to example 3. Okay, so it says example 3, use the equilateral triangle to find the values of sine of 60 degrees, cosine of 60 degrees, and sine of 30, and cosine of 30. The first thing I'm going to do is, so here's this triangle. We have an equilateral triangle, so that means like this was given, this triangle right here, and then this is like the invisible other side of triangle, and it should be this exact same image because it says an equilateral. Okay, so what I'm going to do is I'm only going to I'll use this triangle. You could use this one if you want, but I like this one better because everything is given. Then what I'm going to do is to write out my SOHCAHTOA. Okay, so the first thing we have to do is do sine of 60. And they specifically say 60 degrees. So let's find that out. So sine of 60 is what? Opposite over hypotenuse. So remember in the beginning, I told you it really is very critical to know where your angle is, because your opposite side will be different if it was a different angle. So where is 60 in this triangle? It's right here, right? So can you tell me my opposite side? So here's 60 degrees. My opposite side would be not 1, but actually this side length right here, which is a radical 3, right? And then can you tell me my hypotenuse? The hypotenuse would be on this triangle of this 60 degrees is going to be 2, because this is 2 goes with the biggest angle. Okay. So sine of 60 is radical 3 over 2. Okay. Now let's find cosine of 60 degrees. So we're still going to stick with the 60 degrees. And then cosine is adjacent over hypotenuse, right? So here's 60. Where's my adjacent side? This one, right? And then where's my hypotenuse? It's just 2. So cosine of 60 degrees is 1/2. Let me circle it. And then let's find, what else do we have to, if we found sine 60, cosine 60, and then let's find sine 30. Now this is different. Oh, well, it's still opposite over hypotenuse. But this time, it depends where our angle is. So where's 30 in our triangle? It's right here, right? Here's 30 degrees. Now, can you tell me my opposite side? So my opposite side will not be radical 3. It's actually going to be this one right here. That's my opposite side. And then can you tell me my hypotenuse? My hypotenuse is this 2. So sine of 30 is 1/2. Now, what else do we have to find? Cosine of 30. Cosine is what? Adjacent over hypotenuse. So where's my adjacent side? My adjacent side, here's 30, because it's really important where your degree is. My adjacent side will actually be this radical 3. And then what's my hypotenuse? 2. Okay, so we found all those, sine 60, cosine 60, sine 30, and cosine 30, sine 30 and cosine. So it really just make sure you really know where your angle is, because your opposite and your adjacent and your hypotenuse will be different for each angle. Okay, so that was example 3. Let's do example 4. So example 4 says, let theta be an acute angle such that sine of theta equals 0.6. So there's two parts. It says, for part A, it says find cosine theta, and part B says find tangent theta using trigonometric function. Okay, so what did they tell us? They give us a given. They said that sine of theta is 0.6, right? That was given. Now, on part A, it says we got to find cosine of theta. So if you remember SOHCAHTOA, I think there's two ways you could figure this out. Cosine theta is what? Adjacent over hypotenuse. This is probably the easiest way, the more simplest way. So here's theta, right? Where's my adjacent side? It would be here. So that would be 0.8. And then where is my hypotenuse? It would be 1. So that would be 0.8. Now the other way is probably the longer way. What you're going to do is use the one of your identities, which is we'll do sine square theta plus cosine square theta equals 1. So sine, what they said that sine of theta, this was given, is 0.6, so we can use that. But it says sine, in formula says sine square theta, so we'll use 0.6 square. Plus cosine square theta, we don't know that, so we'll just rewrite that, equals 1. And then 0.6 square is 0.36 plus cosine square theta. Oops. Okay, so we have to find for cosine theta, as you can see, this is a little bit a longer step than this step, but it still works out. So what I did was to subtract 0.36, and then I have this cancels, so you're left with cosine square theta equals 1 minus 0.36 is 0.64. And then we want to find just regular cosine theta, so what we're going to do is take the square root of both sides. We get cosine of theta equals, and then the square root of 0.6 is plus or minus. We're going to use the positive one, which is 0.8. Okay, so that's how you find part A. And then part B says find tangent theta using trigonometric identities. So part B says tan theta. This one's probably the easiest. Here, let me write it here. I have more space. Tan of theta. What is tan of theta? Opposite over adjacent. So here's theta. Can you tell me my opposite side? 0.6, right? This is my opposite side. And then can you tell me my adjacent side, which is 0.8? So tan of theta is, if you put 0.6 over 0.8, you get exactly 0.75. So So tan of theta is 0.75. So that's how you do example 4. Let's move on to example 5. I think there's only like a few more examples. Okay, so example 5, it says, let theta be an acute angle such that acute means less than 90, such that tan theta equals 3, so that's given. Find the value of each trigonometric function using the trigonometric identities. Oh, so actually the problem actually says you have to find two parts. Part A says you got to find cotan theta, and then part B says you got to find secant theta, which we can easily find, right? So what do we know? Here's theta right here. So they're saying that tan of theta equals 3, right? So how we got to find, part A asks for cotangent theta. Remember, cotangent is just pretty much the reciprocal. Cotangent theta is actually x over y, or just the reciprocal of tan theta. So this one's simple because all you got to do is just flip the 3 and 1, which is going to be 1 over 3, right? That's how I remember what cotangent is, just the reciprocal of tan. So that's a good thing because they give us that. Now, let's find secant theta. Secant theta, based on your formulas, is also hypotenuse over adjacent, right? It's just the reciprocal of cosine. What is cosine? Adjacent over hypotenuse, so you just flip it. So here's theta. Can you tell me my hypotenuse? My hypotenuse is radical 10, good, over my adjacent, and then my adjacent side is 1. That's why it's radical 10. Okay. Okay, that was example 5. Let's do example 6. So example 6, we have like kind of like an image, that's my best image. Okay, so example 6 says you are 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along the straight path. So here you are, you're 200 yards from the river. Here's the river, the blue lines. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. So here's you, right? And instead of going that way, you're gonna move like diagonally to this 400 yards along the straight path to the river's edge. Find the acute angle between this path and the river's edge. So what they're asking is, they want to know what theta is, what this angle is. And then when they say acute, that means it has to be less than 90, right? Because this is already 90 here. This forms a right triangle. So the rest two angles must be less than 90. That's why they meant acute. Okay, so what we can do is, first let me write the SOHCAHTOA. Okay, so what do we have? We have a side and hypotenuse, right? So we can't use tangent, right? So what are we going to use? You could find this missing side length by using the Pythagorean theorem, but that's just more work than you have to. And in math, you really just don't want to do more work than you have to, because if you don't have to, why do it? So what am I going to use? Can I use sine or cosine? So cosine says it's the adjacent over hypotenuse. So here's my theta. Adjacent would be this side length right here, but we don't know that side length, and I don't want to do the Pythagorean theorem to find that missing length. You can if you want. you could use the Pythagorean theorem to find, you could do the a squared plus b squared equals c squared, right? But you know what? I don't want to do that, so I'll just use sine, because sine of theta is exactly what we have. Opposite side, so my opposite side is 200 over the hypotenuse, and my hypotenuse is 400. So the zeros cancel, so you're left with sine of theta equals 2/4, or can be reduced by 2, right? So you can actually stop here. You could actually, so what this means is what degree, so this is where you're going to need your unit circle. So go ahead and get your unit circle out, and then based on your unit circle, what degree or radians will give you a sine of positive 1/2, right? So what degree in your unit circle, what degree in radians, I don't know if you could use degrees or radians. So what degrees in radians or degrees will give you a sine of positive 1/2? So you're only looking in quadrant 1 because sine is positive. Are there anywhere else they're negative? Or actually, yeah, we're still going to use quadrant 1. So that would be 30 degrees, right? Because here's 30. Remember, I had a coordinate of an x value of radical 3/2 and a y value of 1/2, right? So yeah, so that's why this is 30 degrees, or in radians, it would be pi over 6. Or what you can do is, do one step further and get rid of the sine by taking the sine inverse. Later on, I think you'll learn about sine inverses. So sine inverse, the sine and the sine inverse cancel, so you're left with theta equals sine inverse of positive 1/2. So what this means is, like I just said, what degree in radians or degrees. Usually they want it, I think they usually want it in radians, but what degree in radians is going to give you a positive sine of 1/2. And as you can see in the unit circle, it's going to be pi over 6, or 30 degrees. And I think that's it. That's all they wanted to know. Just the missing angle. Okay, that was that one. Let's do example 7. Okay, so this one, I think this is the last example. Okay, good. So this is the last example, and this is probably the most, this one is not, probably requires more work than the other examples. So example 7 says, specification for a loading dock ramp requires a rise of 1 foot for each 3 feet of horizontal length. We got to find the length of sides B and C, and then once we find those side lengths, we got to find theta, the measure of theta. So how the heck do we do this? Because you know why? We are only given one side length, right? And then how will we? That seems impossible, because in order to find a missing length of a triangle, you need 2 side lengths, right? But we only have 1 side length, which is the 4 feet. So how are we going to figure out B and C? So what I do is just use what we have. So they specifically said that we have a rise of 1 foot and run of 3 feet. So let's first find B by setting up as a proportion. So they give us a slope of, or slope is rise over run. So they specifically said our slope it rises 1 foot and then it runs 3 feet. So our slope is 1/3, and then we're to set it as a proportion. So based on our triangle, what is our rise? It's going to be 4 feet, right? We rise 4 feet, so we're going to put a 4 here. And then what is our run? It's this side length would just be, we don't know. We'll call that B. And then you can find B by cross multiplying, right? So 1 times B is B. And then 4 times 3 is 12. Okay, so we just found B by setting up by using what we are given and setting up as a proportion. So our B is 12. Now, we can easily find C by using the Pythagorean theorem, right? A squared plus B squared equals C squared, because we already have our B and we have this length. So 2 of our legs, so one of our legs is 4 square, and then one of our other leg is 12, so it's going to be 12 square equals C square. So 4 square is 16 plus 12 square is 144 equals C square. So 16 plus 144 is 160 equals C square. We got to find C, so we got to get rid of the square. So we're going to take the square root of both sides. So C equals square root of 160. Now, this, you don't want to leave it as a decimal. You want this to be simplified. So square root of 160 can be broken down as 16 and 10. Okay, so 16 can be broken as 4 and 4, and then 10 can be broken down as 5 and 2. 5 and 2 are prime, so 14 is 1 pair, so this simplifies as 4 square root of 10. So C is 4 square root of 10. Good. Now, we found our A, we found our B and our C, so we did that. So B is 12, and C is 4 square root of 10. Now the next step is find theta. How will we find theta? So what can we do? So there's SOHCAHTOA. So you can actually use either or. You could use sine, cosine, tangent, because you have all your missing side length. You have all your side lengths. So what I'll do is just I'll just do tan. But you could easily do sine theta or cosine theta. So tan theta, here's my theta, specifically said it's opposite over adjacent. So where's my opposite side? It's 4. And then my adjacent side is 12. Now 4 over 12 can be broken down to 1/3, right? They both can be reduced by 4. Now, to find theta, you can multiply everything by tan inverse. So this would be just theta equals tan inverse of 1/3. Now, go to your unit circle and then see if there is any, in your unit circle, is there any angle that'll give you a tan a positive 1/3? No, right? There's no, in your common unit circle, there's no such thing that'll give you a tan a positive 1/3. So what you're going to do is just, if that's not in your unit circle, you just have to put it in your calculator. So in your calculator, make sure you are in degree mode. And then press, I don't know what kind of calculator you use, but I have a TI 30. So I'm going to use second function, tan inverse button. And then I'm going to put 1/3. And I would get exactly 18.4. So theta is about, I'm going to round it to two degrees, 2 decimal places, so 18.43 degrees. Okay, so that's how you find theta. Okay, and I guess that wraps it up for this section. So yeah, that's it. You have a great day. Bye-bye.